Thank you, Josh. I'm really happy to be here today. I mean, I was sitting here and I had my students calling my phone, like, Dr. Bonner, trying to ask questions about quiz. I'm like, hey, I told you guys I'll be in a conference. So I'm really excited to be here. I'm from Cameron University. I know some, there we go. Somebody asked, does Cameron, how is the ag program? How is the ag program did? I had some good things, not so good things about the ag program, but we've really transformed the ag program. The ag program is doing really great, and I'm excited to be part of Cameron University. I'm Ali Mamifoner. I go by Ali. I'm originally from West Africa, originally from Sierra Leone. You know where Nigeria is? Yes? That's a good question. You have to travel really far, right? Over the Atlantic Ocean. But yes, I am from Sierra Leone, and the population of Sierra Leone is 7 million people, the whole country. So somebody asked, does everybody know each other in Sierra Leone? I was like, no, that's still a large number, right? So I was blessed to grow up in ag because my dad actually was a research extension agent. So he worked in the farm, he worked with farmers. So I was born into ag. I attended school where the big ag center is in Sierra Leone. And I graduated. And I started working with the research station in Sierra Leone. I had the opportunity to travel to other countries in Africa, to Nigeria, Kenya, East Africa, West Africa, South Africa that you're talking about. Had looked at different things as to what farmers are going through from soil health perspective, coming to crop production, and that has significantly helped me in my career journey. And then I later came to the US, to Oklahoma. When I said to Oklahoma, I was talking to my friend. I was like, yeah, I'm in Oklahoma. I came and I'm studying in Oklahoma. And he was like, where is Oklahoma? Because in Africa, you hear about all these other states. You don't actually hear about Oklahoma. So I had to explain to him, and he Googled it. And he liked it because he's a farmer too. So he ended up liking it. I went to OSU, studied with Dr. Bill Ron, may his soul rest in peace, passed away due to cancer. Studied a lot under him, and I worked at OSU for 1 year before I actually started working at Cameron University. So I am the agronomist at Cameron University. I did work from soil to precision agriculture and then to crop production. So I'm excited to be here today. So today, pretty much, we're going to kind of touch base. Brian did a great presentation. Kind of, we all have the background. And the good thing I like about this group is that we have so much experience. So it's just using that experience, right, to go to another level, because we're always learning something. I was talking to Seth outside there, and we're talking about his soil, his work that he's doing, and how the good things that are in the soil, working with biochar and microbes. And he told me, he was like, yeah, everything is going good, but it seems like I still need to learn something more. I was like, yeah, that's the same thing with us. I said, when I was defending my PhD, I had a bunch of professors put me in a room, and they were asking me a lot of questions. And guess what? I didn't know all the answers. You know what they told me? They're like, there's so much more to learn out there. So I'm glad to have this opportunity to be part of that learning process for this group. Element, nutrients. What are nutrients? Why do we need to talk about nutrients? Why do we need to talk about plant nutrients? Usually when you talk about soil health, the first thing that comes to mind, right, is the nutrients. It can either be organic, it can be inorganic, right, or chemical. And we have 17 plant essential elements which are essential. And these are things that sometimes we just think about the bigger ones, which is nitrogen, the phosphorus, the potassium. That's good. But there are also smaller elements or elements that the plant needs but the plant needs it in smaller amounts, so you don't hear a lot more about them. So when people go out and something is happening to their plants, and you buy test kits and you just test for nitrogen, phosphorus, and potassium, what if iron is the problem? What if it was the zinc? So that's why it's always good to know that, yes, there's 17 essential elements, and the word essential, underline the word essential because the plant needs them. Although some of them, the plant needs them in large amounts, some in smaller amounts. So this is kind of like an acronym I use in my class to kind of let people remember, right? Chopkins Cafe, managed by my close cousin, Monica. So that's everything in there, right? It's everything you need to know. The 17 elements are in there, right? From carbon, hydrogen, oxygen, phosphorus, potassium, nitrogen, sulfur, up to nickel. So all the 17 elements are there. So the macro elements, these are the elements that the plant needs a lot in a large amount. So when you're doing soil tests, we want to make sure that, of course, these are in your soil in a larger amount. The nitrogen, phosphorus, potassium, sulfur, calcium, and magnesium, right? They account for a lot of the plant's developmental processes in our soil. And when we look at the micronutrients, the plant needs them, but in smaller amounts compared to the macronutrients. However, they are still essential. From iron to zinc to copper, manganese, boron, chlorine, molybdenum, nickel, they are not less important than the macronutrients. And here what I'm trying to do is I'm trying to lay the background that all these 17 essential elements are important. Nutrients. Nutrients, they move in the soil. They have a tendency to move in the soil. They also have a tendency to move in the plant. However, not all nutrients have that tendency, right? For example, we can break it down into mobile and immobile nutrients. Mobile means they can move. Immobile means they can't move, right? For example, nitrogen. Nitrogen can move in the soil. That's why you can go buy urea and just broadcast it, right? Because it can move in the soil. However, if you buy like phosphorus, a DAP or a MAP, right, you have to apply it close to the plant. Because what happened is that it doesn't move. Phosphorus, potassium, they don't move in the soil. So you can't apply like how you're applying nitrogen. Because wherever you apply it, if it's not close to where the plants can get it, what is going to happen? That fertilizer is going to go into waste. And as a farmer, you're going to just lose money or resources. This is just a picture that pretty much just shows nutrients, how because they're mobile, for example, nitrogen, it has a tendency to be lost. And again, it all comes back to, as a farmer, we need to be cognizant of our resources and our money. An example here, you can get some nitrogen from rainfall. Like, is it possible? Yes. There is a research station at Oklahoma State University. They call it the Magruder plots. And there is a check plot that they have not applied no nitrogen at all for over 100 years, right? And guess what? Crops are still growing there. Every year they put wheat there and the wheat is still doing good. There was 1 year, that plot that nothing has been applied for over 100 years actually outperformed where they had about 120 pounds per acre of urea. So we have some nitrogen from rainfall. Of course, we can get some organic matter from cattle, right, which is also of value. We can fertilize all these different things, we call them addition, that we add into the soil, but they have a tendency to be lost. It can go to our water through either leaching into the ground and end up in our water, which we don't want, right? That is why we're always pushing for soil test. Because I spoke to a farmer not too long ago, and he said how he does things is that he just know that every year he just go there and apply 60 pounds per acre of urea. Every year he just go and do that. And so he was asking me, his field was not doing good. He was asking me why. I was like, well, that is the first problem, right? Without doing soil test, you just go there and apply. So I went there and actually did a soil test for him. I told him, of course, the resources where to go. But I did a soil test for him because I have a small soil testing kit. And guess what was the problem? It was not the nitrogen for sure. It was not the phosphorus. It was not the potassium. It was what? The pH, the soil pH, right? Because he was applying so much, the soil pH became acidic. That means it was low. So he has all these good things, but the soil was not being productive just because the pH was low. So now he needs to raise up his pH. And one way to raise up your pH is to find a lime source, right? Some calcium source. And eventually, if you just apply like that farmer was doing, what happens? Some of it is lost and it goes to the groundwater, which will affect somebody close by that are using that groundwater for either cattle or things like that. It creates what we call an eutrophic zone, wherein if there's a river close by, right, you have algae that's growing in there, and then that causes depletion of oxygen, which eventually causes fishes to die. So we want to make sure that we care about soil tests, just because our rivers, our streams will not be looking good, just because of over applying, which will end up in places like this, which will create these kind of situations. So eutrophication, pretty much that's the big terminology that we use when you have a situation like I just showed, right? You have all those algae growing in the water, using all that oxygen, causing fishes to die. So the big three, nitrogen, all of us have seen it. If not, you have different types. You can have nitrogen from different sources, right? It can be from a chemical source like a urea, right? You can get nitrogen from an organic source, right? You can get nitrogen from the atmosphere, as I just explained just now. And we know it's very important. That's the big guy right there, right? The kind of like the boss, right? It's nitrogen. And it's very important just because it contributes so much to our plants. You think about protein. You always hear farmers, before they go buy a particular hay, they want to know the percentage protein of your hay or of whatever thing they're interested in buying. It's the nitrogen that actually converts to your protein, your available protein. And we know nitrogen is also important in all the things, the DNA, the RNA, which are all the chemical things that goes on. Chlorophyll is also, when you go out there, we see our plants are looking really green, really nice. Hey, that tells you that your nitrogen is really good, right? Organic form, organic matter. Of course, when you think about organic matter, you start thinking about the microbiology part of it, how microbes are very important, which, of course, Joshua will touch on the microbiology part. But organic matter is very important too, not just with the microbes, but also with even holding water, right? The more organic matter your soil have, the more water your soil have a tendency to hold. So that's why going out there on your farm, especially under this so much heat, high temperatures, right? My backyard, I had okra, tomato, beans growing there, and some of them I can see that they're burning, like the heat was so intense, right? So I had to do other things. I had to do things like cover crop. I had to water more. I had to add the organic matter as a mulch, right, to pretty much cool down the soil and for the water to stay a lot longer in the soil. Phosphorus, some of us have seen it, some not. You can get it from different sources, from chemical to organic sources, and it's also needed in large amount just because it contributes to the seed formation. So why do we talk about go buy MAP or DAP or apply organic matter? Because without that, right, in your soil, what's going to happen? The plant is not going to have that energy to actually produce. You can get it from different sources. A TSP, a DAP, a MAP, these are all examples of fertilizers that are out there. And phosphorus can be mined, and of course you can get it from organic source. As farmers, we notice that the rate of fertilizer is going higher and higher. Again, the war with Ukraine and Russia contributes a lot towards that. So we need to look at supplemental ways. Just like Brian said, as we're using chemicals, we need to supplement it with other sources. Number one, availability for these fertilizers. Number two, cost, right? And even number three, with the microbial side of using also organic matter. Potassium, the third big guy, is very vital too when you think about cellular signaling, the cells, how they operate. Think about the tug of pressure. That is when you go out there, you see your plant like it has started falling down like that, like it's sad, right? It gives you an idea that, of course, it's depleting of some nutrient. Of course, water too can cause that because water helps with building that tug of pressure, but also things like potassium helps with building that tug of pressure so that your leaves can...
What about 106 degrees? Will that do that?
Exactly, yep. That is true. It contributes a lot, right, with all that moisture taken out of the soil, you know. So you start thinking about organic matter, mulching to conserve that water because water is the paramount. Without water, it seems like nothing else matters. Sources of potassium, similar to nitrogen and phosphorus, organic, mineral, or inorganic like a potassium chloride, KCl. Soil fertility status. What is soil fertility? We all know when we talk about soil fertility is how fertile your soil is and how healthy your soil is, right? But then we talk about fertility. Let's say somebody have a good soil. The soil is high in nitrogen, high in phosphorus, very high in potassium. The pH is high. Does that mean that soil is a productive soil?
Say that again.
If the soil has really high nitrogen, really high phosphorus, really high potassium, and really high pH, pH of, let's say, 11, is that soil a productive soil? No, though it looks really nice and good, but guess what? If the pH is not right, nothing else matters. Right? Why? Because the pH really controls the nutrient availability. So even if nitrogen is in your soil, if the pH is really high, guess what? It's not available for plant uptake. That plant can't be able to make use of that nitrogen or that phosphorus or that potassium. So soil productivity, we say the capacity of the soil for producing a special plant under a specified system of management. Management meaning that you make sure that everything is right or close to being right. So there are different methods of assessing our soil fertility status. We can do a biological test. You do an experiment, and in my greenhouse and in the field, I do experiments wherein I look at different varieties, winnow wheat varieties that were released by Oklahoma State University or that are in the process of being released. They send them to me. I do research on looking at which variety is the best as far as under irrigation, under well-watered situation, or under drought situation. And then I report the results back to them. And that's kind of like a biological test to help show us which variety will do better in southwest Oklahoma compared to, for example, the eastern parts of Oklahoma. We can evaluate nutrient deficiency symptom by going out there, looking at the plants, be like, this plant looks like it's deficient from nitrogen because of the yellowing, or this plant is deficient from phosphorus because of the purple, and then we apply the nutrients based on our observation. We can do plant tissue analysis by actually taking a section of your plant, right, send it to Oklahoma State University lab, and there's resources out there in case you want more resources as to how the lab works. Or we can do soil analysis. And soil analysis is very important just because when you do soil analysis, you have the tendency to, of course, do your soil pH too. And there are different things that the SWAFU lab, the Oklahoma State University lab has that it tests for. And Josh will go ahead and share the bag. And it has different information that it tests for. All you have to do is get a soil sample. But how do you do good soil sampling? Good soil sampling can be done using a probe, right? You can't just go there and pretty much gather the soil like that and put it in the bag and send it to Oklahoma State University, right? We usually advise that you hold it like that, you go at least 6-inch deep, right? The reason why we say 6-inch deep is because most of our row crops, their roots goes and they stays around that 6-inch deep. However, you can even go up to 12-inch deep, right? And kind of mix it and send it to the lab. There are different ways of sampling because sometimes the cost, you want to save cost. If your land is really flat and you don't see irregularities, right, you can go ahead and collect samples from different places and mix it together and put it in a bag and send it. However, if there are irregularities, like some places are high, some places are low, it's good to differentiate it. Where it's high, you get one soil sample. Wherever it's low, you get another soil sample for that area. So for more information, you can go to the OSU website, their extension website, or there's resources out there that you can grab. So plant nutrient status, it can be sufficient, which is good, which is what we want, right? It can be deficient, which is not good, right? It's not high. Or it can be toxic. And that is a dangerous level to be in because once it's toxic, that means it can affect the plants. And you think about organic matter too. You go get an organic matter, let's say from a farmer, right? And you apply so much. What you need to be mindful of is the salts, right? Salinity. And guess what? You apply so much organic matter, so much chicken manure, or cattle manure, be like, I have a good soil because it's dark but I'm planting there, but it's not coming out, it's not doing good, what's happening? Well, guess what? Probably the salinity is really high. And if the salinity is high, if the salt is high, even if there's water in your plant, what's going to happen? The plant is not going to be able to take that water because the salts make the soil so negative, we call it negative potential, that it even draws water out of the plant. So your plant is not going to do good. Do you have all that? A lot of chicken manure, cattle manure. So when we're doing organic farming too, especially you're dealing with animal dump or animal waste, that's something to be mindful of, the salinity. You always, from time to time, you always want to make sure you do a salinity test. And it's there if you look at this, OSU Soil Lab, it has, if you want to do a routine, that is just the nitrogen, phosphorus, potassium, pH, you can just tick that, number one. If you want to just do nitrogen, you take N, and secondary nutrients, micronutrients, it has organic matter, it has texture, and number 5, it has salinity. So if you're interested in that, you're like, okay, I have so much organic matter, but I just want to test and know my salt level. You can send it to their lab and they'll test your salinity for you. And they'll send back your results. If you give them an email, they will easily just send it to your email. If not, they will post it to you. So this is another way, deficiency through observation. This can be used to, for example, if you see a plant like that, right, your corn or your maize, it's a happy plant, it's doing good. However, if you start seeing purpling towards the side of the plant, right, it gives you an idea that it is phosphorus deficient. If you see yellowing towards the outside of the plant, it gives you an idea that your plant is potassium deficient. And if your plant shows yellowing around the midrib, it gives you an idea that your plant is nitrogen deficient. So this is another tool that we use when we go out to farmer's field. When a farmer calls us and asks about a particular crop, we go and look for these symptoms too, just because we know the big 3 is our nitrogen, phosphorus, and potassium. After that, we can test for other things. But kind of this is a visual that just helps to tell us what's going on. Another example of nitrogen deficiency will look like that. Example of a purple leaf in our margins tells you that, oh, your plant is phosphorus deficient. Potassium looks like that. Gives you an idea that my plant is potassium deficient. And of course, when it comes to dealing with deficiencies, how much to apply based on my land, again, when you do the soil test and send it, they will tell you how much to apply in terms of pounds per acre. Nutrients toxicity, too high can cause reduced crop yields, especially you think about, for example, aluminum is toxic at 25 parts per million for winter wheat. So if you have aluminum there and it's at 25 parts per million, it becomes toxic to the plant, right? Because root growth is inhibited, it creates stunted growth, and of course, you start seeing purpling with low pH. So it's good to be mindful, and again, I'm just trying to reiterate the importance of doing soil tests, because when you think about soil health, soil maintenance, maintaining our soil, it's not just about adding inputs, it's about, whilst you're growing your crops, we're maintaining that soil so that that soil is not depleted to a point wherein we kind of have to start all over again in building that soil up. We want to make sure that we conserve the nutrients that is there by adding just what is needed. Management of soil fertility can apply fertilizer application, especially when you're depleting. It can either be chemical or organic. We can do lime application if our pH is low. If it's too high, we kind of find an acid source like a nitrogen fertilizer pretty much can help too. Good soil and crop management practices is, just like Brian said, is vital for managing our soil. Soil pH, this is a big one. And the reason why soil pH is very good to talk about is just because different crops do well in different pH. So if you're working with a particular crop, know the kind of pH that crop prefers, right? Usually there's a plus or minus planter resistance. However, you don't want to go too far. For example, wheat can do most forages between 5.5 to 7.0. But once it goes to 4.6, right, or to 4, there's a problem. Or to 5, then there's a problem. We need to increase that pH up. or if the pH goes to above 7, it goes to like an 8 or 8.5, we need to bring that pH down. And pretty much this is a figure showing different Oklahoma counties and kind of like an average pH. And pretty much you can see vast difference from east to west, right? We can see higher pH, Panhandle, really high pH, right? And the question is, what do you think is contributing to these differences in high pH as we're coming west compared to the east? Why are they higher pH? So we're coming that way towards that way. We have a 5.5. Rain and droughts, right? That is true. That's it. The higher the number, the more droughts, right? Because all the, let's say, nutrients or nitrogen or urea or things like that, they're not washed out into the soil a lot more. So it's created.
County number, I can't read it. 6.3. 6.3, okay.
Well, does the eastern side of the state has more trees and, than the western side? So does that have something to do with it as well?
So it has something to do with it as far as some of these trees have what we call pheromones that have a tendency to create like a toxic or an acidic environment around that roots, right? So that plays a part, but also, of course, rain water plays a bigger role just because it's washed most of that nutrients down and creates that acidic situation.
I wish we had the 6.3 in this area like it says we do, but we don't.
And again, this is pretty much an average. So some places like where I do my research, right, in Lawton, I tested my field, and the average was like a 7.1. You know.
Ours is 7.5, 7.8.
Yep. So, and if you're thinking about wheats can go up to, it's good, 7.5, I mean 7.7. Once it goes up to 8, then that's.
How does the big farmers lower the pH in a huge field?
So they find an acid source. For example, they can use like a sulfuric acid, or even applying nitrogen, high amounts of liquid nitrogen, can also help with lowering their pH.
Does it have to be urea?
It doesn't have to be urea. Any acidic source, pretty much, any source that has a nitrate or an ammonia in there will help. So this graph here just talks about pretty much the impact of pH. And as I said, if your pH, let's say from 4 to 10, once you start going towards the low pH, what happens is most of these nutrients, they become less and less available. For example, nitrogen, we see this is the sweet spot between 6 to or 7.5, 8. Most of the nutrients are available within this range. But once as it's getting too high or too low, most of these nutrients become less available. Pretty much how we take care of acid soils, like we're talking about, pretty much apply lime to often pretty much a calcium source, a magnesium, or things like that. If the soils are high, pretty much find an acid source of something to apply, some form of ammonium sulfate that has some ammonia or nitrate in it, just help to pretty much bring that pH down. So our soils, Brian talks about our different soils. I'll not go in depth on that one, but we know we have a lot of molly soils. But again, this is changing, right? Because when you talk about molly soils, it has organic matter in there, up to 4%. But our soils now have like 0.5. If you have 1% organic matter in your soil, it's really good, right? And that is something to be mindful about, that we have to increase our organic matter in our soils. Rounding up, this table just shows this is an average, 2015 to 2019 from OSU. They average all their soil tests. They had about 25,274 tests that they do all around the state, right? And pretty much they were able to average the soil pH, right? The nitrates, which is nitrogen, the phosphorus, and the potassium. So on an average, right, just to throw numbers there, it was 7.0 for soil pH, right, like we're seeing. Low nitrogen, of course, so we always have to add a nitrogen source. Phosphorus and potassium, but especially potassium is pretty high in our soil, but phosphorus not so high, but higher than, of course, nitrogen. Here, table 2 just show the distribution of soil pH, nitrates to soil test P, pretty much just breaking it down into different percentages. And then here, this is a graph that just shows the median pH values of soil samples, pretty much like I just showed in our previous, in the previous slide. And this is more recent compared to the previous one, right? This one, OSU just did this one, 2015 to 2019. So this one is a more true reflection of what is happening now compared to the older one in the textbook.
So the green is good.
The green pretty much is around, if you're doing winter wheats, yes, it's still good. It's good because we want a pH around 7, right? Not too far from 7. So again, it depends on the crop, but of course, green is good. It shows that you're within the good pH range. However, it's showing to like, it breaks it down into regions as far as you go in west or going east. So this is a more true reflection of what is going on now.
So anything below 6.6 is good?
So as I said, it depends on the crop. So for example, wheats can go up to 5.5. So 6 is still good. It's still referred to as good if you're dealing with crop. Your nutrients will still be available because remember, it's the nutrient availability that we care about. So from 5.5 to maybe 7.5, you're still within that sweet spot. But once it starts dropping to a 5, then you need to start thinking about how can I increase my pH. All right, I'm running out of time. Let's see what I have left. Rainfall, annual rainfall, of course, this is just to show that, of course, rainfall has an effect of the pH. You see similar trend as far as you think about higher rainfall. I'm sorry, what's going on, low rainfall in the Panhandle area, right? And these are in inches. More. I know. This is just showing the median nitrates when they did the test. When OSU did the test, it's showing the median nitrates as in pounds per acre, and we see they're pretty low. So we need nitrogen in our soils. And soil testing, somebody might ask, what about the soil test kits? The soil test kits are good, but just that you have to be mindful, especially of the different soil test kits that are out there. I mean, there's one, I saw one research wherein they tested different soil test kits, and they came out with some numbers or some, be like, for overall, my soil test kits was good. For soil savvy soil test kits, kind of is closest as far as the accuracy. And then they said a best bang for the buck, the F3 soil pH meter, 3-in-1 soil test kits, pretty much. I have not done this research yet, and it's just based on their research that they did. If you're looking for best chemical tests, they said the Luster Leaf 1662 soil test kits pretty much when you talk about all the soil pH is said did good, and you can get them from Tractor Supply, right, and from co-op companies around your area. However, I always recommend this is the first step. This will kind of give you an idea about your plants. However, always think about, especially when you see that something is going on, usually we advise that you always test at least every 3 years. Send it to OSU testing lab and they will test your soil. Thank you. If you have any questions, please let me know. That's my contacts. You can always reach out to me. Yes?
Okay, I really recommend that you do the OSU test because like this lady's talking about what's your crop. When you fill out that paperwork,
Yes.
then they're going to be making exact recommendations to you for if you're going to grow tomatoes, okra, and cantaloupe.
That's right.
You're going to not have to worry about the pH because those they're going to tell you what to do because of your crops and what you need to use. It's very specific and very helpful.
That is true.
One thing I'd like to point out, Lynn Brandenberger, OSU Horticulture, just retired. He always recommended, it has the list garden there, but even if you're doing a garden, do like Kelly's saying,
Right.
and say specifically what you're growing because they'll give you the recommendation
That is
according
true.
to that.
Yep.
So that'll give you more accurate information.
Yeah, the OU test is for state of Oklahoma, they use Malik
Yes.
3 for your phosphorus. You can't go to some of these other places that offer those soil tests unless you specifically request Malik 3. They don't use it, and there's no conversion.
Right.
You can't convert their numbers to our numbers.
Right.
So OSU is your best bet
Right.
for that,
And here's the, go ahead.
especially for phosphorus in this country.
Right.
So, and the reason that's important, that's why Dr. Forna or Ali Mami, we talked about those different tests and their accuracy. It's because what is the reagent? Like what is OSU using? They decided Malik because they tested it compared to pot experiments, field experiments to make sure they match up. So that the chemicals they put in with the soil to try to do the extraction is supposed to replicate what the plant pulls to its roots. Okay, and if what's in Cornell is not the same soils as down here in Oklahoma or Hawaii, for instance.
That's true. Yep.
Okay, if that's not it, you can talk at lunch. Make sure and go by the OSU Extension. They've got a lot of brochures about soil testing, the cost and such. And I want to thank Ali Mami for presenting to us.
Thank you.